Title of my talk, that one time the threat actor sent me his token. So I scratched out threat actor because I felt like this was like an upgrade, a compliment to these folks sending me these tokens. So, I wanted to change the title, but then I had to go through CAP, advisory, scratched it off, that went under. Yes, so here we are. Give you a little bit of agenda, who I am, a little bit of background. I'll set the stage on how this works and how this happened and how I encountered this. And then, I'll explain once upon a time a Giron ticket, how that happened, and this came to light. And then once I was identified by this Giron ticket, how I hunted across all telemetry. Then I'll wrap it up, and if we have questions, which I think we do, we will. This is a story about the trenches, so it'll be quite short. I'll open it up for some questions. So, who am I? Andy Giron, I'm a security researcher at Datadog, as you can see. Previously, I worked at Hulu. I did IR and CTI at Hulu in the streaming services. And then previously, I also did network threat research at Arista Networks. I used to teach at a college in California in Orange County. Taught IR. Don't do that anymore. It's a lot of time. And then I love all types of malware, so don't discriminate. Really into the Rust. I know everybody's writing that right now. If you want to connect with me, I'm on LinkedIn, and I also play this character in Blue Sky, Pip Zero, so please connect there. Used to be in Twitter and X, but you know how that goes. So, yes. A bit of background on how this all started and what we do, what I do and my team does at Datadog. So, again, threat researcher, we focus on a lot of things. We, as researchers, threat researchers in Datadog, we sit in the lines of incident responders. This is like our bread and butter, but also currently we are sort of CTI analysts, but we kind of merge that and then we work with the product, so sort of improve its capabilities and things. So we do a lot of rule ideation. So I work with detection engineers. I submit them some intelligence briefings and reports on how they should ideate and detect these new novel or obscure techniques that these threat actors are using for exploitation. We do community advisory, so we publish everything in security labs. So this is Datadog's sort of advisory board. My only team is not the only one that publishes there. A bunch of teams publishes there, advocacy, a lot of research. So just look out, that is a great place to keep in touch with all types of research Datadog does. And we do advise on product improvements sometimes, product managers. They got their own ideas and roadmaps. And intelligence collections, so this bullet is in bold, and as well as telemetry hunting. This is what this talk is mostly about. And then we handle emergent vulnerabilities. So just as Max, the talk before, was explaining, a new CVE comes out, it has a logo, a website, full marketing behind it. My team gets dragged into that. We have to either analyze the POC, create a POC, ideate on the detection, let product know they need to improve the capabilities to be able to detect, etc. But that's when we handle that, emergent vulnerabilities. So, quick background, setting the stage. So, we run a lot of intelligence collections, and this is we do this as honeypots at scale. My team deploys a cluster of honeypots all across multiple regions, multiple providers. We don't discriminate on where it is or anything, or the type of stack either. And then we try to collect all this intelligence to see what the threat actors are doing in different regions, and we try to crunch that data to see what's happening. Everything, us being Datadog and us here being at scale, it's all IAC, Terraform, Ansible, CI/CD. Sometimes we have to glue things together. Terraform's not in all cloud providers, and we want to be pretty much everywhere to understand what threat actors are targeting and who, specific regions too. So yeah, all IIC, it's a cluster of honeypots deployed around pretty much anywhere the internet reaches. So shameless plug here. This is a low interaction honeypot developed by one of my colleagues. It's hash, HTTP agnostic software honeypot. It's meant to be like a low interaction honeypot and modified with YAML files. So you could declare any endpoint, any URI, any route with a YAML file, have it return any status code, pretty much any image, any HTML. But it's just the ease of adding, editing YAML. It's low interaction, so it's meant to be initial access, so you won't see any post-exploitation, no second stage command and control, things like that. But it's a great way to start. You'll see who's scanning what, and sometimes the payloads are inline, and headers and things like that. We deploy this all the time. Emerging vulnerability happens. We may make this to be a VPN. We may make this to be Fortinet. We may make this to be anything. And then we just deploy it in the wild and see who's scanning, what their payloads are. And then, we dissect and analyze malware if we need to. So with that, we also have medium interaction honeypots and high interaction. So I developed this sort of medium interaction honeypot called DockerPot. Not to be confused with a DockerPot published. This is unfortunately now open source. It's still internal. The code's a mess. I've yet to figure it out. I've yet to fix it to publish it. It's in my backlog, but so it's like 1,000 things. So yes, DockerPot. It's an emulation of the Docker, an exposed Docker daemon. So it really is a Flask application, and I developed and I wrote all the routes for it for the most common Docker commands. So if you happen to run Docker info somewhere, or Docker, like locally, Docker info, Docker create, etc., you're actually doing like internal local requests, like HTTP GET requests, and you're just hitting a specific route, and then it's returning back some JSON, and then your Docker client is rendering that JSON for you, and then it's showing it to you in a terminal, all pretty, all tables, or in my case, or the case nobody should be using, it's Docker desktop, they'll show it to you rendered. Very nice, but it's all JSON responses. So in the scenario that somebody weirdly decides to expose the daemon, we're talking about just a website, a web app right now. So yes, it's an emulation. There's a database behind it, so if you do Docker create image, or Docker pull, it will definitely pretend like it's pulling an image, store it in the DB. If you do Docker ls, it will show the image is there. So the threat actor is like, oh wow, this is a real instance, but it's just, I'm just generating some random word in the back, sticking it in the database, and then when you do Docker info, Docker ls, I'm just putting that information out. Just simple web app. So as I was developing this locally, I got a Jira ticket opened on my name by the vulnerability team, which was very nerve-wracking. As a security practitioner, I was definitely panicking. So hello, Vuln 3728. So Datadog has this software integrity and trust team, way smarter than me. Developers that do an amazing job. And obviously they use this open source tool, Truffle Hog by Truffle Security. Great tool. If anybody wants to scan secrets, please deploy this into your environment. So, so this team uses this tool to scan our internal repos to see if there's any secrets that have been committed. So yeah, Vuln 3728 came in under my name, and it's like, exposure of DockerHub secrets in GitHub. Like, nah, that's not me. Like, I'm a practitioner. I know how to handle secrets. I know I've never committed these secrets. Like, no way. So looking closely, and we can't really see, but as I was developing this in my internal repo, I pushed the logs, obviously. I wanted to make sure what was going on. This is yet to be disclosed or anything, like published. But these are my developer logs when I was testing the routes, like Docker info, make sure the data returned was accurate, things like that. And then, so I started freaking out a little bit, like, hey, these are actually my logs. Like, what is my Docker token doing there? So doing research, I open the logs and I'm like, oh man, it really is my token. Like I pushed this. How did it end up in Docker pod logs? Completely stoned right now. I'm like freaking out at this moment, doing complete IR in my box, like freaking out. I'm scared to tell my manager. There's like this vulnerability ticket open under my name. Like I don't know how it happened. Like I promise I haven't exposed this. It's been in my laptop. So yes, I don't know who keeps asking for these features, but here we are. Automatic credential injection. That's like what I called it, but it's a feature. Let's just say the least. So if you happen to be, well, I understand the CLI portion. If you happen to be authenticated to the Docker desktop locally, obviously, and you, let's say, run any Docker command, your local request or your Docker commands will be authenticated with your token. So either you have the option of creating an application token, or you had the or Docker itself will append your username and your password to DockerHub and send that token locally. Okay, fair. But what if I don't have, what if, for some reason, I'm trying to run commands on external instance of Docker. So now, with the CLI, okay, I purposely did that. I went to the config and I created my application password there, or I put my DockerHub password there. But with Docker Desktop, this was the main problem. I was using Docker Desktop. So yes, if I run Docker H, pointing it to an external host, create image, info, ls, etc., and I am authenticated to Docker Desktop, my Docker token will be sent to the external Docker daemon. And this is for a feature request, somebody put in, that if I want to pull a private image from a repo, etc., it will be authenticated, and I get to authenticate, and now I pull that image from the private repo. So, okay. And then, again, we're sending the X-Registry-Auth header. So, okay, this is what happened. So, what is this token? What I should have just RTFM, obviously. So, again, what I just explained, you have the option of creating an application token, which is, you can authenticate to DockerHub. It's just meant for the application. That this could be do for automation, for Docker Desktop, Docker CLI, etc. And then if you don't do that, Docker takes the opportunity and appends your username and your password and sends that as well. So this is what this token is. So I read this and I was like, okay, this makes sense. I don't know who asked for this again, but again, I blame myself. I shouldn't have been using Docker Desktop. So, but as soon as this happened, obviously myself being a practitioner, breaker of all things, like a light bulb went into my head. I was like, I wonder how many threat actors don't know they're authenticated and they're sending me their tokens. Like, whoa, cannot wait. So obviously we have a lot of honeypots deployed in the wild everywhere. So decided to hunt for this X-Registry-Auth header, see who has been sending me this token. And as you can see, it's very blurry, but I had around, in total, and this is as of early this week, 141 unique users sending me their registry-auth token for DockerHub. So, meaning if I really wanted to go and decode all those tokens and found out those tokens that don't create an application password, that means I have your username and your password to DockerHub. At the very least, if you did create an application password, I have your username. Like I mentioned, I'm sitting between IR and CTI. I'm going to take that username and just go down full rabbit hole. I'm sure I could attribute it. And if I do get your password, I hope you're not using a password manager. I know that password's unique. I will take it down and go to the rabbit hole. So, show you what I did. So, decided to do some analysis here. Started to group by them. I was like, okay, let me do some grouping, some live statistics. See how many people are sending me how many tokens and seeing what's going on. So obviously I blurred the tokens out, don't want to get Datadog and anybody in trouble. these are all tokens. As we could see, we have a number of it's grouped by. So I'm grouping the token. So I have like the person that sent me the most tokens is 31 tokens, and we have 6, 4, 4, 4, and so on. And some folks just send me one. Again, now this could easily be that a victim's computer or victim's box is compromised, and it's being used as a pivot point, and they are authenticated to DockerHub, and from there they're scanning my honeypots. So hence why we're sort of blocking the tokens. I don't have full attribution for everyone, but for the ones I do, we'll definitely talk about. So I'm going to take the first one, the 31, because you definitely been scanning me. I want to know who you are. So I did a little bit more grouping. Datadog, we're same logs, whatever we want to call it. So I group the token per IP address. So how many IP addresses have been scanning me with this specific token? So I see this, and I'm just like, 31 times, multiple IP addresses, you're scanning me at scale. You definitely got a botnet going on, or at the very least, you got a lame script scanning me, but you are. And for the analysis, you could look at I don't know if you could see the IP addresses, but the subnets match. This is one person. So either he was too lazy to even switch regions from wherever he's at, and he just literally deployed another box, right after he deployed another one. And then maybe later on we see a 5997, 5996, then 11729. Okay, maybe over here he switched providers. All right, fine. And then, or he might have switched regions. But okay, he's trying a little bit. I give him that, trying to be evasive. Cool guy. So yes, I see them. So one token, multiple IP addresses, all belonging to the network. One subnet, or relatively very close, I could assume. Definitely, no hard attribution, definitely no high confidence yet. So yeah, perhaps a botnet, perhaps not. So what do I do? What's in this base 64 anyway? So again, like I mentioned, it's just base 64. I pipe it in the command line, see what's going on, and hello, Raven 1. I see you. I got you for sure. Luckily for him, unfortunately for me, he created an application password. So his scanning instance, etc., CLI, Docker Desktop, had an application password. So it wasn't that he did not create one, and this is his DockerHub password. Luckily, he was smart enough to do that. Perhaps he's a very good developer. But I still have his username. Means I could go hub.docker/u/raven1. Hello, sir. This is you for sure. I see you trying to scan my honeypots, and you're sending me your token, and you're authenticated here. So, all right, he has one image that is published. Cool. Let's rip this apart. Let's see what's going on. Perhaps you committed some secrets here as well. So just looking at the image here, never heard of this. It's Vaza, okay. But looking at the layers, inspecting here, nothing really catches my eye. We're setting up infrastructure here. I do see this I'm setting up this command, the Flask command of this long string. And then obviously us practitioners, we dealt with cryptocurrency before, and as much as we would love to catch state-sponsored and highly sophisticated threat actors, this is why I scratched this off. It's not really a threat actor. I'm familiar with the type of data we get. We get a lot of mining, opportunistic folks who try to make a buck. So they're mining, they're creating an image, and they're provision XMR, or they're provisioning their own cryptocurrency, whatever it is, and then they're using my honeypot or instance, wherever they find, to mine Monero or mine a cryptocurrency. So as soon as I saw this string, it's like, oh, okay, you have a miner that is published here. Let's go check if this blockchain is published. So again, security researchers at Datadog, We come from IR. We still have like, PTSD from those days. And then, but we sit in the middle of CTI and IR, so it's like, okay, let's go down the rabbit hole here. So I take this sort of address, and I'm just like, oh, it's called a chia. I've never heard of this token. I mean, there's so many altcoins, sorry about that. Altcoins, alternative coins, so many alternative coins now that not aware. So I was like, oh, let's look it up. And then, I look it up and it's like, I'm sorry, saddest miner ever. You only collected $4 so far, but perhaps he's getting started. No judging here, everybody, support the hustle, I guess. So, yes, so case study number 1, went down the rabbit hole, and definitely found them. This is high confidence. You were definitely scanning me. I know when you submitted your token, I know the command you appended to my honeypot, you were trying to spin up a honeypot, cryptocurrency miner. Went to your profile, you also have a cryptocurrency published image. So, yeah, for sure this is you. Scenario number 2, just going down the rabbit hole here. I picked the last one, Let's see who you are. Hopefully I find a password here. So, again, not high confidence here. So I give the user the benefit of the doubt. Perhaps he got popped. Perhaps his box is a pivot point to be able to be scanned. I mean, got to think both sides of the house. So blurring out the names just because medium low confidence here. But something to note here is that this user did not create a application password. So Docker did this feature, again, that appended his username to the password. And lovers77db, that's not a password, randomly password generated. Interesting. Again, so I pivot to his, so with this password, obviously, we could utilize it for various things. I have his username and his password for DockerHub. I'll leave you guys with that. But again, the ends don't justify the means here. So we're practitioners, and we try to stay ethical. So, but we do have these tools. I have various tools exposed to my in my sort of jump box, etc. We have this tool called SpyCloud. Weird business logic, but kind of cool. So what the SpyCloud does is they purchase all the stealer logs and all exposed credentials in the internet from every stealer possible. And then this tool is meant to be sold to research teams, malware analysts, CTI teams, to be able to perform sort of attribution and go down the TI rabbit hole and things like that. So I was just about to disclose the username. Don't want to take his username and search it. It's very, very broad. So, okay, but lover77db, very, very smoking gun right there. So I do a little bit of, sort of fuzzing here, there, and then I fuzz the password to be able to search my DBs, and sure, of course, you'd be surprised how many threat actors have been compromised by all the stealers. It's like there's no respect in this area. So yes, I find this person, I find his username. Of course, there's there's like a little change in the password. Maybe it doesn't go from loversDB exclamation. Maybe it's lovers78db exclamation. And of course, we all do this as humans. Before I got into security, my password was, my brother's name, and I might have changed his name from exclamation to lower, used the 0 instead of an O. Not anymore though, obviously. But yes, so going ahead, I pivot from him, pivot from his username, I collect his tokens, decode his tokens, get his password, fuzz it a little bit, submit it to our tool, get all the passwords that have sort of relatively resemblance to this, look for something that is definitely familiar, and it's like I end up with this email address that it's blurred out because I have medium confidence here. Don't really want to expose this person. But yes, I go ahead and I follow up, and it's like, yes, you scanned me from this area. I see your IP, you're scanning me, and the command you attached to the create image was very well developed. So, Mr. DevOps engineer, this could be you. But again, medium interaction. So nothing crazy here. Medium confidence, nothing crazy here. So this is just another example of like how all these opportunistic folks are just trying to make a buck and perhaps even learning. We practitioners, I might have done some gray area stuff as well when I was learning, and we've seen the news, all these rock stars later on wrote some malware 10 years ago and then they get caught, well, that's what it is. But again, here it is. So just want to wrap up, give you guys some perspective on how threat actors are doing, and and please don't use Docker desktop. Like that was just my problem. But with wrapping up for my hunting, I do want to sort of note something here. Boundaries. So I have these folks credentials. I have these folks users. I have these usernames. So like I mentioned, we can cross over from passive to active. If not, we're just like everyone else who we talk about and who we try to defend and who we hate and who we get paged about. So yes, there's no such thing as active intrusion. That's bullshit. It's, unfortunately, we lose the battle. We can't hack back. It's just the ends will not justify the means. So this is something I want to leave you with. Of course, all these credentials, obviously all truncated, all defanged. Some of them are straight up credentials, not all application passwords. But just want to give you guys know that we will lose, and it's not fair. But it is what it is. This is where we're at, and we just can't set the new norm of go pop the threat actor. That's just going the wrong way. But we do also do industry collaboration. We do what we can. I work with the Docker team, Docker security team. I ping them. I'm like, hey, we have a shared instance. I'm like, hey, folks, well, a bunch of your users are potentially violating your terms of service. They're executing code in an instance that does not belong to them. All I could do is report to you guys and obviously protect Datadog's customers. All this intel has been disseminated and it's all being enriched to Datadog K9 customers. That's what Datadog security products provide. But yeah, like I said, whether Docker did something or not, they didn't, but that's another story for another day. But yes, all I could do is report them, collaborate with the industry, and let them know. And I wanted to know something that this research or this instance, this feature, has been previously researched by Trent Michael in the notorious Team TNT. This is a TA we actively track as well. This is back in the day when he first appeared. It was the first notably known threat actor targeting microservices, or who was knowledgeable enough of like the cloud and stuff like that. So just want to know that he has been caught, not in the real world, but he has been caught sending tokens to Trent Michael's honeypots. We know his identity, we submitted it. He does commit other mistakes, but like earlier talk by Andrew, it's like when you're in this like Eastern Europe or I wouldn't even say that. It's just when you're not in the States or in the Five Eyes, it's like when you get to receive a cease and desist, it's like, cool, some Americans caught me, dope, I'll continue exploiting. So With that said, I'll leave it up for some questions, and if not, it's been a great conference, and yeah, thank you. Sure.
I know you say you don't discriminate malware. This one's kind of a one-off fileless malware.
Memory?
Yeah.
Yeah. I mean, I read this quote by this like science instructor once, or somebody. It's like, malware can hide, but it always has to run. So at one point, something loaded that. But yes, I'll dump the memory. Let's look at that. That's my favorite. Because at that point, what are you going to do? Encrypt? I'll pull that key. So, yeah. But in terms of why I don't discriminate, it's like everything, the whole world is reading on C, C++, but now we have Go, we have Rust, all these cool things. So I love looking at those. Like it takes me out of my comfort zone. I'm just like, what are these fucking syscalls? Like, what's happening here? So love all that new sort of language and stuff. And I don't develop Rust. I don't develop Go. I barely write Python. It's just, but it gets by. So I'm a researcher. I'm a POCer. I write code and make it work. Cool. All right, y'all. It's been a great conference. Thank you.